Hello everyone, welcome back to the video lecture series of Basic Electrical and Electronics Engineering. I am Sajitha and the topic which we are going to discuss here is the back EMF that is produced in the motor. So generally the back EMF in the generator output of a motor and so is proportional to the motor's angular velocity omega. It is 0 when the motor is first turned on, meaning the coil receives the full driving voltage and the motor draws maximum current when it is on but not turning. As the motor turns faster and faster, the back EMF grows, always opposing the driving EMF and reduces the voltage across the coil and the amount of current it draws. This effect is noticeable in a number of situations. When a vacuum cleaner, a refrigerator, or a washing machine is first turned on, the lights in some circuit dim briefly due to the IR drop produced in the feeder lines by the large current drawn by the motor. When a motor first comes on, it draws more current than when it runs at a normal speed. Adding a rheostat in series with the field winding can increase the voltage drop across the field winding and reduces the magnetic field strength. When a mechanical load is placed on the motor, like an electric wheelchair going up a hill, the motor slows, the back EMF drops, the more current flows and more work can be done. If the motor runs at too low a speed, the large current can overheat it through the resistive power in the coil because P is equal to I square R, perhaps even burning it out. On the other hand, if there is no mechanical load on the motor, it will increase its angular velocity omega until the back EMF is nearly equal to the driving EMF. Then the motor uses enough energy to overcome the friction. Now let us consider an example where any rotating coil will have an induced EMF and in the motor it is called as the back EMF since it opposes the EMF into the motor. Suppose you find that the belt drive connecting a powerful motor to an air conditioning unit is broken and the motor is running freely. Should you be worried about the motor that is consuming a great deal of energy for no useful purpose? You can just think over it and also explain why or why not. Now, we can also say the various kind of applications of generators and the motors. The following are some of the uses of the DC generators. The DC generators are used to compensate the voltage drops in the feeders. The DC generators are used to power hostels, resort, and workplaces, among other things. And the DC generators that are individually stimulated are utilized for electricity as well as illumination. The series DC generator is employed in lighting arcs as a steady current generator and as a booster. This is always a thorough description of DC generators based on the facts presented, and we can infer that the primary benefits of the DC generator are its easy construction as well as the designs involved in it. So again the next question comes, so what are the applications of the DC motor? So from the previous classes, can you please state few? Yes, washing machines, mixers.